Hi, so I'm going to show you the results of a point cloud that are generated from the depth maps from ARFoundation. So, for example, here is an RGB frame, and its corresponding depth is an EXR. The reason is because in Unity, if you try to export a PNG that has values of more than 1, it'll just generate garbage basically. So I had exported as an EXR, and I had to use a different API than Unity's because otherwise it wouldn't generate depth values more than 1. But anyway, you can visualize EXRs in like Tev, which is a pretty great program. So for example, this is a depth map that was generated. You can see the depth is in the R channel at the top, so up here. And then finally you get a confidence map from ARFoundation, which looks like this. I'm going to normalize it. So in this particular frame, it seems pretty confident about the chair, the painting, and some of the table. At least it says that it is. We're going to test that in a second. So I am going to do this. Okay, so here is a single point cloud. So from the image perspective, this is what it looks like. I have this feature depth-based scale, which will sort of normalize the scale of the points in image space. So here are the points. I get a bunch of points, and in image space it looks basically the same as the RGB frame, except it's lower resolution because the depth map is lower resolution. And then the point cloud itself looks like this. So the camera frame is here. This is where it thinks that this chair is. Clearly it's pretty distorted. Right now I'm just visualizing the entire depth map, not the most confident points. But anyway, this is where it thinks that the chair is. This is where it thinks that the table is. Obviously it thinks the table is way longer than, or the table size is definitely distorted because it shouldn't be this long. This is where it thinks the painting is. And it said in the confidence map that it was confident about the painting. You can see the painting is pretty white, but obviously the painting is really distorted in the point cloud. And the TV is way back here, and the TV is supposed to be that, the TV is supposed to be pretty far away, but the entire, like the actual depth is probably not right, because first of all the TV itself is pretty distorted because it's so far away, and it also thinks that this part up here, which is the wall on top of the TV, is much closer to the TV, probably because the TV reflection is confusing it. And then this here is the light that's going downstairs, and this should be flat because it's a wall, but ARFoundation obviously can't tell that from this distance, so it just kind of creates noise. So let's show only the most confident points. If I visualize only points that are more than 90% confident, there actually aren't that many. So you can see it seems pretty confident about this corner of the chair and the very top of the wall here. And that's about it. Those are the only things that are more than 90% confident. It's really confident about these points here, which I think belong to this chair back here. But this chair is not supposed to be this far away. Or at least, I don't think it is. So these are probably false positives. The confidence is really, it's clearly just what ARFoundation is confident are the same features between two frames, but it's not the confidence that the depth itself is actually correct, because it's just using like SIFT or something. So anyway, let's visualize points that are more than 50% confident. Okay, so we get a little bit more. We get part of the painting, which makes sense because in the confidence map it says that it's confident in part of the painting. And this is the part, it's a little less distorted than what we saw before, because it's still clearly not flat, but it's not horribly distorted. It's still pretty happy about this side of the chair. It's pretty happy about this part of the table. Now these points on the table are actually like pretty flat. so that's nice, but they're obviously not angled that well. My this visualizer, it takes into account the camera perspective. So if this were correct, then the table should be aligned with this axis, but it's not. Obviously these black points over here were part of that folding chair, and you can see how distorted it is because these points should not be spread out so much. And it seems to like this part of the floor that's under the chair. So let's visualize some even less confident points, and then we'll look at a couple of other frames. So this is more than 10% confident. You can see that it's more than 10% confident about the painting. The painting's still distorted, of course, but it's still not. There were some points that were really far away from it, so it got rid of those. It's getting some false positives around here. These are part of the floor reflection, so they definitely should not be table height. The table itself is still kind of flat, but it's not oriented the right way. It's getting a little bit more of the chairs, and it's getting false positives for that very bright part of the wall over here. So yeah, confidence matters. All right, let's look at a couple of other frames. Let's look at this couch frame, for example. Let's do, I don't know, like a little bit after, because after it gets more confident about points the longer it sees something. So I want to grab a part of this couch that has been seen for a while. All right, let's go with 633. So we'll do 633 to 634. Doesn't really matter because I'm skipping frames. Also, let me only visualize. I want to visualize everything at first. All right, so from an image space, this looks pretty close to the RGB values. And here's the camera perspective, and then here is the depth map. So you can see the window is really horribly distorted, which is usually the case for windows when you try to reconstruct them. The wall itself is still pretty distorted, like this part here is really warped. It still creates almost like a surface, but yeah, it's definitely not like planar like it should be. The rug itself is actually not bad, except for this part over here. This chair over here is kind of in the right place, but it's distorted. The couch itself is not that bad, to be honest. At least relative to how distorted other things are. This doesn't seem too bad. So let's look at the most confident points. I'll look at 90% or above. Nothing. Okay, see total point 0. So it wasn't confident about anything here. Let's do like 70% or above. Get 10 points. So this image frame in general is not very confident. Let's do 50% or above. Alright, we get a little bit more. It's like parts of the couch basically, and false positives at the window, and part of the side of the window. Alright, let's do 0.1 or above. Okay, so 10% confidence is basically just the couch, some of the rug, and false positives of the window itself, and this part of the wall, which is kind of warped. But it did remove a lot of the noise by using 10% confidence. Alright, let's look at another frame. I'll use maybe this door. This door should be pretty confident, I think. It doesn't have many features, so that may be the biggest problem in terms of the point cloud. But we'll see. I'll use frame 951. I'm doing 10% confidence still. Alright, at 0% confidence, we get this. So the door, it's clearly distorted still. It should be aligned with the y-axis, but it's not. It's not that bad though compared to like the couch walls or the wall that was near the table. It's not as bad. But the floor is definitely not in the right place. Look at that. Alright. Let's do 10% confidence. Alright, it removes a bunch of noise in the door, but it obviously doesn't fix its overall shape. It removed a lot of the floor. And that's basically it. It's like a 0.5 or more confidence. Basically nothing. Alright, well, that's just sad. Let's move on. When ARFoundation does tracking, it's really just trying to track edges. So I'm not sure it really cares. At least as far as mobile AR goes, I don't think it actually cares about any of the non-edges. That's why I think that the non-edge parts, like the white part of the door, just tend to have really bad depth maps in ARFoundation. Because it's something that it doesn't need to do tracking for mobile. And when it comes to mobile AR, you really just want as much data as you need to track the camera correctly. You don't really care about the quality of the depth map. At least they don't. I do, because I do reconstruction, but we have different goals. Alright, let's look at the island. Frame 2001, I guess. 2001, 2002. This is 50% or more confidence. So you could see that you can already see the island is really distorted. Like these tan points belong to the top of the island, and they are scattered really hard. And it's also getting a bunch of false positives around the lights and the balcony door. Well, not false positives, I guess. These are, like I said, these are probably confidence of the features being the same feature as it saw in the previous frame. Not so much the quality of the depth map. So these are 50% or more confidence. Let's visualize the entire frame real quick. Here's the entire frame. So the very corner of the island is okay at first, but then it starts getting more and more distorted. You can see it gets the shape. Well, in image space, the shape of the balcony door is right, but it starts getting really distorted. And the kitchen cabinets are really distorted. And the fridges, as you would expect from reflective objects. Alright, let's do 10% or more confidence. Okay. The frame overall is so distorted that I'm not even sure it removed anything that we can clearly see a difference from. Oh, I already did 0.5. Alright, anyway, it's just not a great frame to test on. Let's do one more frame. I'll do the couch. Okay, so this part of the couch here should be pretty good, because I saw it twice at this point. Because I looked at it and then I turned around to look at the other part of the couch and then I turned back. So if I go to frame 3303, you should see a good couch, but obviously we don't, because this is 50% confidence or more, and all it really gets is the pillow itself, and I'm not sure what these blue points are. 3303. It's a reflection on the floor, so obviously those are false positives. So that's not great. You can also see the confidence map here. So 3303. confidence map is actually kind of noisy itself. Let's see if there's a really good confidence map we can try to use. Okay, so 3168. Not sure which frame that is. I think it's when I was looking at the other part of the couch. 3168. I'm gonna visualize the entire frame first. And yep, there's this part of the couch. Apparently it says it's confident, so the pillow shape is pretty distorted, but it's not that bad. I mean, I guess it looks more or less like a pillow. It's kind of skewed in this from this angle though. The couch itself, I mean, it's continuous at least, so it's not bad. And the edge of it is also continuous, so it is distorted, but I could see why they were confident about it. The wall itself looks a little bit better than the other couch wall. And the window itself is pretty bad, but you would expect that from a window. Alright, so points where it's 10% or more confidence. Alright, you can see that, I don't know what that part is, I guess it's a house nearby. 3168. Yeah, that's a house nearby. So it seems to like the house outside, it likes the pillow, and it likes parts of the couch. Let's do 0.5 or more confidence. Let's see what we get. Probably just the pillow. I don't know, see, it got a decent amount of the couch and the part of the pillow. I'm really surprised that those white points inside the window are really highly confident. Alright, so 0.9 or 90% or more confidence. Still get the pillow, the building outside, at least part of it, and parts of the couch. So, yeah. Anyway, this is just looking at point clouds. Hopefully it helped show you why you shouldn't be doing reconstructions from point clouds that are generated this way, at least. These are from the depth map itself. So if you've used TEV, you can see the depth map like this. And same with the confidence map. Confidence you can store as a PNG because its values only go from 0 to 1, but in depth that's not the case. Alright, that is it for this demo.